Now, this one again is one that I think you should have looked at it back in primary school, year 5 or 6. It's the idea of being reversible or irreversible. And this had a little bit to do with our previous video about states of matter as well. So again, it's presumed knowledge, things you should already know. If you need to revise it, please do. So the idea of states of water, those 3 changes in states of water, we often use that as an example because it's one we all have experience of day to day. Investigating irreversible changes. Think about rusting, burning, cooking, and then exploring how reversible changes can also be used to recycle materials. Now, I'm not going to talk a lot about that, but you will have probably looked at that at primary school because of really good use of our knowledge of this area. So, when we change states, we're doing what's really reversible. That's why we can do it. So we've got water as ice. We add more heat energy. It melts. So the particles are free to move around more. And we get a liquid, water in this case. If we add even more heat energy, then those particles are able to move even further apart. And if they're not in a sealed container, then they become gas and take up the space. Now, of course, the reverse happens. We can reverse that. We can take heat energy out of here and condense that back to liquid, back to water. Or we can take more heat energy out and bring it back to ice. So it's all about the amount of energy present. The matter hasn't changed. Water, we haven't really talked about this yet, but we will. Water is 2 hydrogen atoms joined to 1 oxygen atom. So water is H2O. The ice, liquid water, water vapor are all H2O. The only thing we've done is change them physically from being ice, water, or gas. So these are reversible. I've just gone through that in great detail, haven't I? I've got slides for it. Anyway, so add heat, melt. So we talk about melting, making solids, take the heat out, solidification. We also talk about evaporation, condensation, and this idea of sublimation. So if I jump from being an ice block to being water vapor without being liquid in between, then I've what we call sublimated. So I haven't been liquid. And you can go the other way, back from water vapor to the ice block without being liquid, and again we've seen sublimation. We've jumped a stage. So it's a fancy word for jumping a stage, basically. I think I've probably done it to death as well, haven't I? So heat energy is added or removed. So if this heat energy is added, we expand the spaces between the particles. If heat energy is removed, then we compress them. So it's all about energy. And then we have things that are irreversible. So as you'll be well aware, you put some paper in the fireplace and it burns and you don't have paper anymore. So paper is essentially carbon, hydrogen and oxygen, and there's some other elements there as well. So when you burn it, you basically release all those as gases, and you might have some carbon left here in these bits of paper, and some other minerals with the carbon. You might have some other elements that have gone off as gases as well. But what you've basically done is reorganize the matter. As we'll talk about later, you can't destroy matter, you can't create it, but you can change it. So in this case, we've taken that paper, that carbon, hydrogen and oxygen, and reorganized it. But we can't get the paper back. It's gone. So that change is irreversible. Another famous one, of course, that we all see quite regularly is rusting. Rust is always a problem with metals, because metals exist in the Earth's crust as ores. So an iron ore is iron with oxygen attached. Bauxite, aluminium ore, is aluminium with oxygen attached. So the metals naturally form compounds, more complex bits of matter, with oxygen. So basically we take that ore from the Earth, we smelt it in a huge furnace, like we've got here in the picture, create a pure block of iron, and from that moment it starts to rust because it wants to react with the oxygen, and so we've got to treat it in such a way as to stop that happening. So in a sense it's reverting back to being the ore, It just takes an extremely long time. And we probably haven't got the energy available to do that. But rusting is one of these irreversible forms. Oops, no, I'm finished. Clearly, we can use that sort of knowledge to recycle things. Those objects which we can pull apart and get material from that we can reuse, we can recycle. If you can't, then there are things we can't recycle. We end up putting them in landfill. Although there's now talk of burning them to at least release the energy from that product and put the energy back into the system. There's also problems with that too. Anyway, it was a quick one, that one, wasn't it?